say. So this is just a rough image I'm taking.
Yeah.
So it's not a high resolution.
Mhm.
Just optical microscope also we can see. This is
Yeah,
52x.
Okay.
But this system can go up to like 100,000, 120,
Yeah.
200,000.
Oh yeah, I want to
That's
see the
around-
little
Yeah.
granules.
Yeah,
and the
yeah, yeah,
melanin.
yeah, yeah.
Oh, so excited.
So we have two computers here. There is a path here. Okay.
Yep.
Source control. Click OK, and then VGA.
Okay.
Okay. So it will, because we have two computers,
Yeah.
one monitor. So and then here we have AZ Tech. Okay. You
Okay.
can hear. This is the software. It's an auxiliary software. We have an extra detector for that. Aux
Okay.
cord. So that is the detector
Gotcha.
that detects EDS signals.
Okay.
Okay. So this is the software. Now you can see it is giving you a path. So and you are here, right, Lauren?
Lauren in capitals, right?
Okay. So I can give you one. Today is 15.
Today is
14.
14.
Okay. 10, 14, 2019. So can you give me the sample name?
Let's call it SEM1.
SEM1. Okay. So we can give anything is fine, right? SEM1 0. Okay.
Okay.
So TIFF 16-bit grayscale image. So that's fine.
Okay.
So now, if you wanna move like this and then take one more image, maybe we can take one more image.
Is the top, the higher part of the feathers where it's really, really blue.
Okay, yeah. But blue thing we cannot see here.
Right, right.
So we can take a couple of images and then we can go to high resolution and see. And then if you really want to map this one at this level, we can map it, or maybe we can go to high resolution. So that is up to you.
I think higher resolution.
It would be better, right?
Yeah. Yeah.
So where actually in these feathers, or maybe are these in main, maybe where you wanna look at?
A little bit higher up
Okay.
in these thinner areas,
Yeah. Okay. We can.
because that's where the majority of that blue color is.
Okay.
And I want the structure of that blue color.
Okay. Okay. You can see. See, the 150 seconds is really good because I don't see any charge effect.
Okay.
So you can. We can take one image like this.
Yeah.
So these are just low resolution. So,
Yeah.
but we can go to high resolution. So.
Okay.
This is scale bar is like 500 micron.
Okay.
That means it's around 5 micron or something like that. So if you wanna do it like this, maybe you can. This is 2.77 millimeter. Something like that. So. So, do you have any location? Maybe we can look around here.
Yeah.
Okay.
Yep. That's fine.
Yeah. So now. So let me. Yeah, this is kind of focus, right? So take an image. This is only 249x.
Oh,
So
wow.
optical microscope outside,
Yeah.
normal microscope can
Right.
go up to 1000x.
Right.
So sometimes you may see these things, so I just need to fix that. So means sometimes detectors, I need to toggle it one time and then it will be fixed.
Okay.
So that can go to 1000x.
Right.
So some optical microscopes, they are integrated with some software. So that software can enhance the magnification. That is digital magnification up to 5000x.
Okay.
but this is very powerful, like we can go to 200,000. Even we have TEM,
Yeah.
transmission electron microscope, but we need special preparation for the sample.
Yeah.
That microscope can go to up to 1 angstrom, even we can see 1 angstrom.
Oh wow.
Okay, so let's see. Oh, sorry. These are to shift that one.
Okay.
I thought maybe that one. So, this maybe I can go to 3 kV because I don't want to burn you. So you can take sometimes reduced window like this.
Yeah.
And then okay, and okay, like this maybe. This is only less than 1,000,
Right.
so I can go maybe around here. Maybe
Yeah.
we can see.
Yeah.
I would suggest let's change the detector to TLD. So it
Okay.
will give you more details.
Okay.
But this ETD detector won't give you details.
Right.
So it's just an image. Maybe it may, give you like good impression, like to see.
Yeah.
But the details, like the morphology or
Right,
structure, you
the
cannot see.
structure,
So
right.
see, everything is same for me, entire thing.
Yeah.
But you can see surprisingly different things when you move to detector TLD and then immersion mode.
Cool.
So you'll see the details.
Yeah. That's what we want.
But the thing is, we need EDX mapping. That one is different.
Okay.
So now what I'm gonna do is, so I just need to activate the immersion mode. Only thing is go to TLD,
Yeah.
okay, and then just click auto brightness contrast one time,
Okay.
and it will give you like this. And then what I can do is, it's already highlighted here.
Okay. So
Click on immersion mode. Okay, and one more time, auto brightness and contrast. This is not in focus right now, so you need to focus. So the fine.
Yeah.
Can you see the
Yeah.
details?
Yeah.
So thing is, like 20x the view is only less, right? So now if you wanna see this one, okay, you said on top, right? On top of the feather or
Yeah.
somewhere, right?
Yeah.
So this is the thing. Maybe I can move to somewhere
I think we were in the right area.
here, right? So now this is the feather. So we are at 2 microns, so I'm gonna take around 5 micron first.
Okay.
See the details, and even we can go to 500 nanometer.
Okay.
500 nanometer is too close, and then see the details.
Okay.
So I think my chest congestion is still there. I need.
Yeah. I was just in Colorado over the weekend, so I'm just very dry.
Yeah.
Oh, excuse me.
So, did I say that? I don't know.
I think it looked like it. I saw the little file.
Check this one. I don't know whether I saved it or not. Where are you?
Yeah.
We saved it. But the thing is, I don't know why, because
Oh, interesting.
what I'm gonna do is like I'm gonna take a little low resolution also, maybe like this, yeah,
Yeah.
one image, and because these are the end of the feather, right?
Right, three
Yeah.
different barbs.
Oh, okay, branches.
Yeah, branches. They look like branches, and then you go from barbs to barbules to barbulettes or something.
Okay, okay.
Something along those lines. I can't remember off the top of my head.
So this funding is from NSF?
No, it's from the CCC College Foundation.
Okay.
Yeah.
Kind of state. Huh? State funding.
No, it's so the foundation money. I don't know where that comes from. To be honest, they do some fundraising.
Okay.
But yeah, they have they offer $50,000 a year for faculty to do projects with students.
That's good. Yeah.
Yeah. So this is my second one.
Oh.
So we have about, I think we have like $6,000 left to spend, and I just got an extension through August.
Okay. See, this one is
But I did decide I'm going to be using this data to apply for
next one, right?
an RUI. So that'll be an NSF.
Yeah, check with Jacob. He's the coordinator.
Yeah.
He doesn't know maybe. Our director is changing. Like our Professor Selmira, he's now more than 80. He's stepping down. He
Okay.
already stepped down, and then our associate director Christian,
Yeah.
he became an interim director now.
Okay.
So I think you check with one of
So
these guys.
Dr. John is no longer.
No, John is here. John
Oh,
is here.
okay.
John is here. He's the coordinator, right?
Okay,
But
coordinator.
what I'm saying is like if you can have a collaboration kind of thing,
Yeah.
then you may get some benefit, right?
Yeah.
So like you don't need to pay that much money.
Yeah.
So if you really wanna be in research field, so
Yeah.
they are supporting some seed grants, so for first
Nice.
time users. So
Yeah.
try to
I'll have to talk to him.
yeah.
Dr.
So
John
if
about
you
that.
you can avail that. So if you are getting some like $500 to $1,000, so still you can use the
Yeah.
system.
So yeah, we have the money. The money, the RUI is going to be to try and buy out some of my teaching time, so I can spend more time doing research with students.
Okay.
And then also we're trying to make those REUs, the mini ones for students, but we just don't have funding for it. So
Yeah,
I was
you-
going to
when-
write that
when-
into the RUI.
Yeah, you just need to write a small proposal and then.
Yeah, I don't think it'll be huge or super long.
No,
but
maybe
I-
1 or 2 pages.
Yeah,
So,
yeah.
so yeah. So
And I'm thinking.
check with him. Yeah.
Latest I want to submit by February so that maybe I would get funds for the summer for the students.
Okay. So these are the ends of the branches. So okay, let's go here
Okay.
and then go to maybe 1 micron.
Yeah.
So are you planning to write any papers on this?
Any what?
Papers, publication?
Yes. Yep. I have a manuscript in prep right now that's about the feathers.
Okay.
And
okay.
so, especially for the XRF or XPS.
Yeah,
I
that's
can't
good.
remember
Yeah,
which
that's
one.
good. Yeah.
Because the results are interesting, but if I can show that there are heavy metals in one population and not in another, or just any heavy metals in general in the feathers,
Okay.
and correlate that to the color,
Okay. Do you
that'll
see
be
is there any blur effect there?
a blur.
Yeah.
Maybe.
Little bit, right? I need to check. Because anyway, I'm gonna save this if you don't really like it. So thing is, you need to take this and then need to check. Not there. That's good. And little. I think explained you what I'm doing, right? So I'm trying to align that beam at the center.
Okay.
So I can give you one more time. So I can tell you one more time. So
Okay.
see now
Yeah.
this is at 1 micron. Now what we can do, we can map the low resolution at low resolution and then this one also. So
Okay.
you are particularly interested in this area, right?
This area, yes, but more magnification.
More magnification means you want to see more close?
Yeah.
Okay.
Yeah.
Okay.
Because at some point we should be able to see the little these granules of melanin interspaced with keratin,
Okay.
or sorry,
So
it's
no-
keratin interspaced with air.
So now 1 micron. So I'm going to more close now around 500 nanometer. See now. Take an image.
So I'm wondering if the black areas are
Gaps.
the gaps in the
Yeah.
air. And
So
then the
that
rest is
those
gonna
are
be
in the,
the
like
beta keratin.
nanometer scale bar. Like we have 500 nanometer. If you take, so that's around, let's say 50 to 100 nanometer gap.
Okay. So yeah, we want to get into those gaps.
Let's see if I can go. Now it's already we are, because this microscope has a little vibration
Yeah.
effect, like when we are going to higher magnification. So because of some pipes going through the top, so
Yeah.
they are rattling. So
Okay.
those are like 59 Hz. They're imposing onto this column. So
Okay.
we can see that. But let's try now. I wanna go there and then see. So now we are at 300 nanometer, still good. So let me focus this one.
Wow.
Focusing is not so great. To see that, what I can do is, now we are at 5 millimeter because we are looking very far.
Yeah.
So what I can do is, I just want to go little closer. Okay.
Okay. And now will we have to turn down the
Magnification we can turn down. We can coming up because I'm just
or and
trying.
then these here.
And that's fine.
Okay,
That's
those are
fine.
still good.
So now I'm gonna go here, and I wanna go a little closer, and then trying to focus, and then now we can go here. Now we can focus. Sorry. Yeah, you need to clearly identify where we are. So So thing is, we are at 162,000. Yeah, 162,000. So I'm gonna take help of the software. So there is a
Okay.
knob here, autofocus. So
Okay.
let me see if it can give you
A
it
better,
better,
yeah.
because my hands maybe. So at this magnification, we need to consider a little bit other things, speaking, like, so check everything is fine.
Yeah.
So one thing I did, autofocus.
Yeah.
Another thing is, now I need to check whether the beam is completely aligned.
Okay.
See, now little bit is there, so it should be like this.
Okay. I forgot what we were looking for there. Could be just straight back and forth pulsing.
So now
Yeah.
this one is there. So you have one more option here, direct adjustments. So now we are here. I think it's fine now.
I was gonna say,
Little
that
bit.
looks better.
So yeah, this is just a minor adjustment, but it doesn't make it makes sense at high resolution.
Yeah.
But if it is low magnification, so you don't need to worry.
Okay.
So now take one more time this one. I don't know. Maybe we need to. We did everything. So yeah, that is the maximum we can get, maybe this area.
Okay.
So not so great image, now around 210, 200.
Okay.
Let's take an image. So even blur, that's fine.
Yeah. Okay.
Not so great image, but thing is, we know what's there. Like
Yeah.
this is like 200 nanometer.
Wow.
See, this noise is coming up here.
Mm-hmm.
The 58, if you can measure between two peaks.
Mm-hmm.
So that's noise. So we already measured like 59 Hz. So the AC noise is 60 Hz.
Okay.
So it's not from AC power lines,
Mm-hmm.
but somehow these water pipelines are rattling.
Wow.
So these noise is from. So I don't think it is going to give you good contrast there, but
That's good.
yeah.
Like looking
So,
at that, because we know that, because I know that the
around
those blacks-
500, so you will get nice image.
Yeah.
And then I need to make sure you have a nice image. That's fine. Once you focus there, move away from that area because you already burned there.
Okay.
So let's do the color map. This is
Okay.
high resolution, we
Yeah.
got it, right?
Yeah.
So let's do the color map and identify what are the elements there.
Okay. Cool.